successful in this class and beyond. So the cube root function. The cube root function is really the inverse of a cubic function, right? And what do we know about inverses? Their x and y values are swapped, right? We switch the x and the y values when we work with inverses. So why don't I just do the cubic function first, even though it comes next? Okay, so the cubic function, if I plug in 0 for x, I get 0 out for y, right? 0 cubed is still 0. What's 1 cubed? 1. What's 2 cubed? 8. Already off the charts. That cubic, it gets like really, really tall, really, really fast. Now, what is the degree on this polynomial?
Positive.
Positive, yes. What's the degree?
3.
It's 3. Is 3 an odd number?
Yes.
Yes. And you might recall that odd functions have origin symmetry, meaning that they're like a rotation of 180 degrees around the origin. So what I can do with a cubic function is I can graph one side, and then I could imagine rotating it around the origin 180. So the other 2 points that I would graph would be -1, -1, and -2, -8. So I've got an oddness about it, right? Anytime you have an odd function, it's going to have rotational symmetry. Okay? And the reason why that works is because negative numbers to an odd power are still negative. Okay? If it's an even power, they become positive. But if it's an odd power, they can stay negative. So the inverse of this function would be taking the x and y coordinates that we just got over here on the cubic and swapping those. So 0, 0 swapped is 0, 0. 1, 1 swapped, still 1, 1. 2, 8 swapped is 8, 2. And then similarly on the other side, -1, -1 swapped, stays the same. And then -2, -8 becomes -8, -2. And just pointing out a couple of different things, yesterday we talked very extensively about the square root function, and it only had sort of like one part of this, one little tail. And the reason why is because it's the parent function of x squared. If we were to make the inverse of that, we'd have 2 parts and it wouldn't pass the vertical line test, right? It would look like this. It would look like a sideways U. And so it wouldn't pass the vertical line test, so we just keep the top part of a square root function. But a cubic function doesn't have that problem. If I take the inverse of a cubic function, if I get the cube root, I don't run into an issue with not passing the vertical line test, so I can use both sides of that. Okay? So that's another one that's an important function to remember. Okay, so let's describe each of these functions, how they are different from their parent functions, meaning describe the transformation, and then graph them. Okay, so together we can start with g of x, x plus 2 squared minus 3. What's the transformation? We're not going right to. We're actually going in the opposite direction. Yeah, so remember that horizontal shifts. Anything horizontal really is going in the opposite direction of the sign. So we're going to go left 2, and then we're going to go up 3. And this is a parabola.
Down.
Oh, did I say down? Did I say up? Oh, okay, good. Thanks. Okay, so it should be down 3. All right, so left 2, down 3. And it's a parabola. So then from that vertex, we're going to preserve those key points that we had been using the other day, where we're going to go out 1, up 1. And then we're going to go out 2, up 4. And then if there's space, we're going to go out 3, up 9. And then we could go out 4, up 16, So let me have you and your partner do the next one together. And if you don't have a partner but you want one, you could move. Brian could move back and sit next to Sophia. Eric's open and so is Sophia. So you can work together. Partner work is great.
So you go left one, left one.
Does it look like this?
It's actually really good.
I think you're wrong, Eric. It's just like.
Really, you have the power.
Okay, so what
You
do I
got
do?
the power.
Wait, what do I do?
You grab it.
Well, I was gonna say
Okay.
just the next one.
Okay.
And Kylie's gonna put the answer up for us.
Oh, whoa.
This is actually the coolest thing I've ever done. Not gonna lie.
Okay.
Wait, did I do it? No, I didn't do it right.
Oh no, ¿qué pasó, Victor?
I did the wrong. I didn't memorize my absolute value.
Oh, you were like thinking square root.
It's really hard to draw a straight line.
I'm not
I
doing
tried.
it. She is.
Okay.
I tried. It's really hard to draw straight lines. Can you correct my other line? That one right
Oh
there.
no, we're not gonna do that. It's fine. It's fine. You get the idea, right? Okay, so it's an absolute value function, which you gotta remember that. So it's like the V. Okay, got moved to the left 1, up 4, and then got reflected vertically. So now it's going down instead of up. Okay?
Told you.
All right. Hey, we got a cube root function again.
That's exciting.
What might we need to do before we do anything else?
Check it out.
Oh, you can't just cube stuff just because you feel like it.
Negative.
Ah, factor out that negative. Okay. Now, if we were solving, yeah, cube it. But if we're simplifying this to graph it, then we want to factor that negative out. Now, here's the thing, and this is specific to odd degree roots. That negative on the inside of the cube root could as easily be on the outside. Why? Because what's the cube root of a negative number? Negative, right? So that negative number, that negative on the inside, could be moved to the outside, and the effect would be the same on the graph, okay? The effect would be the same on f of x. So what is this? It's a cube root. It's getting moved down and to the right to,
And it's reflecting over the y, or the y.
and then it's reflecting either over the y or the x, depending on how you want to look at it. Because that negative could stay inside or be moved out because of the nature of a negative odd root. Okay, so I might even say that. I might even write that down. Or negative cube root, x minus 2.
So with odd
Minus 3.
roots, negative on the inside does the same as negative on the outside?
Yes, that's correct. And you'll see, watch, like, so if I were to take a cube root function to the end and record. Okay, if I were to take my cube root function and I were to reflect it either horizontally or vertically, it would look the same, right? Think about that little snaky S. I can flip it this way or this way, and the effect is going to be the same on the graph. So, we just have to remember that instead of going up 1 over 1, I'm going to go down 1 over 1. And then I'm going to go down 2 over 8. Okay, 2, 4, 6, 8, yeah. What? Okay, so look at your cubic.
Yeah.
1, 1, and then 8, 2, or going up 2 over 8. And so, but now instead of going up and over, you're gonna go down and over because of that negative.
Down 3, right 2.
Oh yeah, down 3, right 2 to get to the, like that,
Okay.
what do we call it? The point of inflection. And then from that point is where we're getting those other key points.
Did you go 7 or 8?
Well, it's 8 from that point of inflection.
Oh, from like this.
So from like, it's not called a vertex because it's not like the bottom or anything, but yeah, the point of inflection, 8 from there. Yeah. Okay, and then same idea with the next example. We've got a cubic. The negative is on the inside. So I could rewrite this as negative x minus 4 and then cube it. But that negative right there being cubed on the inside is the same as just putting a negative on the outside. So the effect is the same. So if I were to describe it, I could say reflect over the x or y axis. It wouldn't matter because the overall effect on the graph is the same. So this cubic function is going to have a point of inflection that is to the right 4 and up 1. And then instead of going up to the right, it's going to go down to the right. So far, so good?
So far, so good.
So far. Well, then I think it's time to summarize. Okay, so in the space below, on the next page, it says, in the space below, summarize what would be done to the x coordinates or the y coordinates if a graph were shifted, reflected, or stretched in any direction. Okay, so horizontal shift, horizontal shift, add or subtract to the x coordinate, vertical shift, add or subtract to the y coordinate. I'm using those ditto marks to just say the same thing that's above. Back in the day before you had copy and paste on your laptop because you like took notes by hand and stuff, we would just put ditto marks to mean copy and paste. Copy and paste. Okay, let's see. We've got a reflection over the x-axis would make it would negate the y values. And if we reflected over the y-axis, we would negate the x values. Okay, what about a stretch? So vertical stretch would multiply y values. What about a horizontal stretch? We actually haven't talked about that really much yet. But here's the thing. I've been saying this, the last couple days. Anytime it's horizontal, it does the opposite thing than what you think, or it does the opposite direction of vertical. So if a vertical stretch multiplies the y values by a particular number, then a horizontal stretch will divide the y values, or excuse me, the x values. Okay? All right, so we've been talking a lot about parent functions, and parent functions are incredibly important. You have to be able to understand what's happening to these graphs. But not all functions are given by equations that have nice continuous graphs. Some functions are given as a set of ordered pairs, right? When you were back in Algebra 1 and Algebra 2, just learning about what is the definition of a function. A definition of a function could be an equation, a set of ordered pairs, or even some other kind of mapping of numbers to other values, right? The only thing that is really important here is for it to be a function. For every input, there can be one and only one output. Okay? So, or excuse me, just only one output. So, let's say we have this function up here. It's f of x. And its domain is just -3, -1, 1, 3, and 5. We don't connect the dots or anything like that. These aren't lines connecting these points. These are the values that you input, and then f of x, the input, or excuse me, the output would be 5, 1, -4, 1, and 2. That's it. So what happens if we decide to make g of x, it's not very easy to see, is it? If we decide to make g of x equal to -f of x plus 2. So what are we essentially doing here to the function? Let's talk about it in general. What are we doing to that function?
Reflecting.
Okay, so in terms of like x values and y values, are we doing anything to the x values? Nothing. There's nothing on the inside there of that function. So we're not doing anything to the x values. We're leaving x alone. Just quit picking on it, okay?
What?
Quit picking on x. Leave it alone. Because this function doesn't do anything to the x values. It does, however, transform the y values. What is it doing to the y values?
Negating it.
Negating them and adding 2. In what order should we do that? Negate first and then add 2. So we're going to take 5, negate it, and then add 2. So what do you get? -3. Okay, now let's take 1, negate it, and then add 2. 1. So you could fill that one down there again. Okay, -4, negate it, then add 2. 2, negated, and then add 2. 0. So the transformation of that function under g of x would give me a new set of ordered pairs, -3, -3, -1, 1, 1, 6, 3, 1, and 5, 0.
Jen,
Yeah.
why don't you change the x coordinates?
Okay, so in the different types of transformations, anything that's going to change x is going to be a horizontal transformation, and those changes happen on the inside of the function. So if like you had an f of x plus 2, and then close the parentheses, that would be on the inside, so that would move the x values around. But anything that's on the outside of f of x, that's a vertical transformation, and that would affect the y coordinate. Okay, so great question. Let's do an example. So 3 times f of x plus 2 minus 3. What's happening to the x values?
They're moving to the left.
They're moving to the left. So if they're moving to the left, what are we doing to them? We're subtracting, right? How much are we subtracting from each x value? 2. So we're taking 2 away from each of those, because horizontal transformations always go in the opposite direction of the sign. Okay, so this f of x plus 2 in here is telling me go to the left. So I'm going to have to subtract 2 from each of the x coordinates. All right, then the other parts of this transformation are happening on the outside. So that's the multiplication by 3 and then the subtraction of 3. Those have an effect on the y-coordinate. So what are we doing to the y-coordinate? Stretching it and vertically, yeah. Stretching it and then what? And then moving it down, right? Because that minus 3 out there. So I'm going to multiply the y value by 3, and then I'm going to reduce it by a value of 3, or by a 3-unit amount. So I'm taking 5, and I'm multiplying it by 3. What is that? 15. And then I'm going to reduce that by 3. So I've got 12. Whoa, I don't want to do that. Okay, so I've got 12. All right, 1 times 3 is 3. Then subtract 3 from that, get 0. Okay, negative 4 times 3 is negative 12. Then reduce that by 3, negative 15. We already did 1. And then 2. 2 times 3 is 6. Now go down 3, and you get 3 again. Okay, so the new ordered pairs under this transformation would be negative 5, 12, negative 3, 0, negative 1, negative 15, 1, 0, and 3, 3. Okay? Feeling good? All right, you and your partner do 3 and 4. You can do it. Eric, you're a fellow lefty. Not this lefty, this Eric. Yes, lefties.
I'm a lefty.
How many lefties in the room? You're not a lefty. I'm not going to be your friend anymore. Just kidding.
For this one?
Yes.
So because it's a minus, we add it to
Yes.
right? It's just adding a positive to it. Or do we add
Because you're thinking about, like, this is essentially moving the graph to the right. And anytime you're going in the right, to the right, you have to add 2.
So like for negative 3, it becomes negative 1.
Yeah.
So that's
There's usually a lot more lefties. So Eric and Victor are my lefty people in here.
Yes.
X?
Do you negate it first?
I would. Yeah, because if you
You
think
would.
of, I
It's a
would.
completely different answer.
Because if you're thinking about order of operations, if f of this is just y, you're gonna negate it and then add 2.
I guess.
Yeah. I mean, if you were gonna get it right, you would want to do
I
that.
would shoot for
You,
that.
yeah.
Okay. This one is gonna reflect, negate the x's, and subtract 3. That's 0.
Still like, you just factored the negative out. I'm confused on when you
That's what-
factor out the negative, do we then add a 3?
Yes. So what you're gonna do to the x values is you're gonna negate them, and then you're gonna add 3.
Okay.
Yeah.
Okay, back.
Okay.
Okay, so how do you do this?
Okay. So, all right. The effect on this one is moving to the right 2. So you're adding 2 to the x values, which you've done.
Yeah.
Okay.
Like that.
Now the y values you have to negate, and then you're gonna have to add 2.
So you negate the 5, so it's 5. And then you add 2, it's 7.
Okay.
So
So
instead
5
of-
negated is negative 5, and then add 2 to negative 5.
Negative 3.
Yeah.
Okay.
Okay.
Thank you.
You're welcome.
Not right 3, we should write plus 3, because we're doing new
All right. There you go.
Okay. Do I just write the answer?
I had somebody in another class ask a very interesting question, and nobody's asked it yet, so I'm gonna ask it of you. If I factor out that negative right here, then I get f of negative x minus 3, right?
Do I do the second one too?
Can that negative come out in front? We did say it could come out in front earlier, didn't we? What was that for? That was for like a so an odd degree polynomial or an odd root. So what about here though?
It doesn't work with parentheses.
Yeah, we don't know what this function is. This function isn't an algebraic function. So we can't assume anything about its qualities algebraically, that it's odd or even or whatever. So because we can't assume anything, we wouldn't want to put it on the outside. Thank you. Okay? All right, did you get the same things?
No.
Oh, almost? What's a little different?
This thing.
Okay, so we do want to factor out that negative, right? Don't be so profane.
Sorry.
So what are we doing here? With these x coordinates, you want to negate, and then you want to add 3.
I thought we were subtracting 3.
Well, once you factor out that negative, remember you got to factor it out. Once you factor out that negative, then you go in the opposite direction.
Does the negative still affect the x?
Yes, it does still affect the x.
So you don't look at the original one you're trying to
What do you mean the original?
this was like
You're talking about that? No, you don't look at that. You have to look at it once it's factored out. Yeah. So your x values would have been wrong. No, yours is right.
Oh, I didn't do it like, okay.
Wait, but didn't you move to the, you reflected and then you added 3?
I did positive 3 plus 3. I just changed the.
Oh, okay, so you were looking at that.
Yes.
So what I want you to do is I want you to think about taking the negative out and what the effect is here. Guys, you guys, I love that you love each other. I love it. Okay, so with this problem, you've got to factor out the negative to understand the transformation on the graph, even though you might have gotten the numbers correct. So understanding the transformation on the graph, this is going to be a horizontal reflection, so a reflection over the y-axis, and then it's going to be moved to the right 3. So when you're taking your x coordinates, what you're going to want to do is negate them and then add 3 to each one. Okay, we will do more of this next week. Please get started on that first problem set and on that web assign, because Friday at 4 p.m. next week will be here before you know it, and I don't want you to underestimate the amount of work there is to be done.
The packets that you gave us yesterday.
Yeah.
The packet and the online.
I would just say get started on it. Like you could at least do the first page on the packet, if not more.
Ms. Jones, we have to do the packet and the online.
Yes, there's almost always going to be a paper component and then an online
Is
component.
the online as much as the paper one?
In some weeks it's like the online's more and the paper's less, and then some weeks it's this way. So next week I would say the online is more and the paper is less. And then the following week the paper is like humongous and the online's no big deal.
Okay.
So yeah.
Do we have enough information to finish the packet this weekend?
Maybe not finish it, but you could definitely get a good start on it.
Okay.
So
Stressed during the week.
yeah, I don't want you to be stressed either.